Hello, everybody. I will introduce you to Lukas Schmierer, who will talk with us about or talk to you about building services in FHIR and Go. And yeah, I'm very thrilled to hear it. Stage is yours. Thank you.
Hi, everybody. Thanks for having me. Right, like you said, I was talking about what we do with FHIR and Go. A little bit about myself. I'm the team lead of the health integration team at DAMEDIC, a startup based in Cologne, Germany. What we are doing is basically medical coding software and service. Medical coding basically means converting text like discharge letters into codes, like ICD codes for diagnosis and OPS codes for procedures. My FHIR journey so far, I started doing some FHIR stuff in a research department of the University Hospital in Leipzig a few years ago, where in my free time I figured or tried around a little bit with FHIR and Rust. I built some Rust models in FHIR which support the JSON XML serialization, but I'm not working on that anymore. But was fun. And I think it's pretty fast. I did not do any benchmarking, but just the way everything is compiled into the static code with generics should be quite performant, but I don't know. When I joined DAMEDIC about 2 years ago, we actually started to do some Go stuff there. First, let's talk about why are we even doing that. For our services or what we offer, we need access to the patient documentation. That is mostly still HL7 version 2 in German hospitals, but very often there are just no interfaces at all. So we just have to go to the database of some system and get everything we need. And for that, at some point we decided if we need to build like this database accessors and then work with the data in our system, let's just look for something which we can use. And then we said like FHIR model makes sense. So we built like thin FHIR-Facades on top of this databases. And then the other question, why Go? When I joined the company, a colleague of mine just tried around a little bit with Go. I think his concrete use case was he just needed to do generate some CSV reports from a database. It was running, he needed to be running on a Windows machine. All the developers at our place are like working on Mac or on Linux. So he looked for different options and found that Go can easily cross-compile static binaries to for other platforms. So of course we could have gone with Python or with Java, but then you need to install the JVM, and it's always a little bit of setup. And this way we just give the single executable to the customer, he can run it, and that's it. I took over that project and was also my first contact to Go. And I thought like, oh, it seems pretty nice. It's quite fast. The compiler is quite fast. Like a small or mid-sized project typically compiles in a few seconds. The standard library is very powerful. You can do like many things just with the standard library, like building production-ready web services, for example. And in general, I like the simple and clean syntax of the language. And last point, this is a thing that the Go tool, which ships if you just install Go, has a formatter built in. That means just all discussions about where to put the opening brackets and where not are just killed. You never need to argue about code style because the compiler just forces it on you. So maybe debatable, but Go was a language created by Google. I think 2012 was the first stable release. And since then, it got a lot of traction in like the cloud native space. For example, Kubernetes is built with Go, and also some monitoring stacks like Prometheus, Grafana. So this is like an area where it's used a lot. Regarding the language, you can see it's somewhere on the spectrum, maybe between C and Java, Python, kind of. It's managed, garbage collected, so you don't need to figure around with memory issues like in C maybe. But still, it's quite basic, more simple language which is less expressive than maybe, for example, Kotlin or something like that. It has interfaces, but it does not have like classical inheritance with classes, like you maybe know from Python, from Java. Yeah, Python kind of. So what I'm talking today about is our open source project, fhir-Toolbox-go, which is like less of a framework, but more of like a set of libraries where you just take the individual pieces you maybe need for your use case. So we have model structs generated from the FHIR spec. Those, for example, observation you can see on the right. Those implement JSON and XML serialization and deserialization, of course. Then we have a helper, some helpers to build like FHIR REST services upon it, which I will go into in a second. And lastly, this is more a thing I did in my free time, more for fun. We don't use that in production right now, but we have a FHIR path implementation in Go. So how would you approach building a FHIR service using this stuff? Everything a server can do in our system or in our project is modeled as an interface. So for example, this is the observation read interface, which has just one method, read observation. And to implement this capability, you implement this interface. In Go, interfaces are implemented implicitly. That means that if your struct implements the read observation method, it implements this interface. You don't see like an implements observation read like you would, for example, in Java. This has, of course, advantages, disadvantages, but that's just the way it is. So you define your backend. In this case, a simple dummy struct with that, which has no fields. You implement your interface on it. In this case, it just returns a static mock dummy resource. Then you use your instantiated dummy backend, put it into this new server call, call listen and serve, and there you go. There you have your simple basic server running. I can actually show you this in code. This is like exactly what we've just seen. Even do it a little bit larger. There's a demo backend, our dummy observation, instantiate, start the server, and we have it running here. Query observation 1, 2, 3. We get our fake observation with ID 1, 2, 3. Of course, we have the capability statement also generated based on the methods you implement. We see this server only supports as an observation resource and only supports the read interaction on this resource. If we look at another example, it's called the mock example, then we see that this example server also implements composition resource and also implements a search on it. For search, you actually need to implement two methods for search for resource type. One, the search method itself, and then a method which returns like the search capabilities, because search is like more complicated. You can support different parameters or not support them. Yeah. And the third example I can give you is it's called the proxy example. You give it another FHIR server, and what this is doing, it just forwards all requests to this other FHIR server. In this case, I put in the FHIR test server, and if we search for patients without any search parameters, we just get the answer that the FHIR server just gave us in the background. Because it is just a simple example, I did not implement search capabilities forwarding on this, so it just returns empty capabilities. But still, this proxy example, which is of course nowhere production ready, very basic, probably lots of bugs in it, but it's just like, I don't know, 140 lines of code. So the framework or the fhir-toolbox-go actually handles a lot of like this REST handling stuff where you read the request, parses the parameters and stuff, and yeah. Let's look at a little bit behind the scenes. How does this actually work? In the end, it's just a long compiled switch statement. And it uses a feature which is in Go called type assertions, which means like if we get a request for an account, for example, then we check if the account read interface is implemented for our implementation. If so, we just call the method on it. If not, we return the operation outcome. What I showed you so far is what we call the concrete API, where you have individual interfaces for each resource type and interaction you try to implement. This is ideal for building facades, like I showed you, where you have custom backend implementations for the individual resource types because you need to implement different SQL queries or whatever where your data comes from. The alternative is the generic API, where the resource type is actually passed as a string to the method. And what you then can do with this generic API is like build adapters. No? For example, you can think about implementing caching or authorization. I thought about like I currently cannot handle like search includes. I think this is something you could, for example, also handle with such an adapter. And what we can do then is you can grab a concrete implementation in a generic adapter or vice versa, so it's like interoperable. So for example, what we don't have right now, but what could be possible is to also build a FHIR client with this. And this would probably be like a concrete API where you can call like search observation, search whatever. And in the background, it translates to this generic API and does the REST calls. So where are we today? We have simple facades running with this in production with our customers. But what I meant with the name of the talk, building simple FHIR services in Go, I didn't mean that like it's super simple with everybody use our library. It's super simple. This is for use to decide. What I meant is like it's still limited, right? You can do simple use cases with it, but we are nowhere like close to a full capable FHIR server, and that's also not our goal. Right now, we did not do a stable release of this module because we are the only users, and it makes it very easy for us to iterate and improve on the API. Also, I would like to get some external input if somebody is interested in that, but I don't have any rush to do like a 1.0 release up today. Yeah, what we learned from that is that Go is highly productive. Like I said earlier, when I used to do stuff in Rust, what took me about 3 weeks in Rust, I probably got done in 3 days in Go, no fighting with the compiler and so on. But it's a flawed metric because if you do the same thing a second time, you always be better in that. And for us, it's like a good way to build like this custom implementations. So what's next? Still a little bit what I'm looking into right now is how to better handle search parameters. Because like I said, you have these methods which return the search capabilities. I'm thinking about maybe just putting the FHIR search parameter resource in there, but then search parameters often support multiple resources, so you have like an end-to-end problem there. I didn't figure out a great solution to that yet. Custom operations, maybe the missing interactions like version reads, history. We don't need that right now for our use cases, but I think it's important to have to be like a good set of support. The includes, like I mentioned. And the latest Go release has an experimental support for a new JSON serialization library. So JSON v2 is the name of the package. And I would like to upgrade to that because it's supposed to be much faster, less copying in the background. But performance is not like my main concern or our main concern right now. We didn't do any benchmarks and so on. And like I mentioned, API stabilization. And if I have 1 minute left, I can show you a thing. Like I mentioned, we have a FHIR path implementation. And what I did recently is Go can compile to WebAssembly. And I compiled the FHIR path engine to WebAssembly. And what we can show you here is the Go FHIR path engine compiled to WebAssembly running in the browser. So this is all running in the browser, no calls to backend. And I think it's like the only alternative to FHIR path.js, which can do like in browser FHIR path execution. There's a pull request open at Brian's FHIR-Path lab repository. I think until this library is stable, it's not going to be merged. Just will be sit there. I will keep it updated as things change, and let's continue with that. Thank you.
Thank you so much, Lukas. I will definitely go give it a try in Go. Who else? And who has questions? Vadim has.
Hey, Lukas. Thanks for your presentation and thanks for working on this library. We can always use more open source libraries for FHIR. I previously implemented similar facades in C# and I found it was time consuming to cover every resource, every search parameter, writing that code by hand. Have you put any thought to expediting that somehow? Because there's 150, 160-ish resources in FHIR and a lot more search parameters.
Right now, we're leaving this to the implementers, but since we have this FHIR-Path implementation, you could, in theory, build something with that because all the search parameters are defined as FHIR-Path expression, if I'm not correct. If I'm correct? Yeah, but this is, as we have like other third-party databases in the background, which we do not control, it's really difficult for us anyway to implement all these search parameters. So we only implement that what we really need and just implement that as hard code. In our own code base, which uses that, we have like a very basic query builder, which depending on search parameters just appends a where to the SQL query. Yeah.
Thanks a lot. And second question is, we're all humans, so we can make mistakes. So have you thought to adding any sort of validation, either run compile time or run time, but you're not filling in a valid file like, patient, diseased, birth, diseased Boolean, and disease date time is filled in at the same time when it shouldn't be. It's a polymorphic type.
We have no validation in there. I think there's also no really usable FHIR validation library in Go out there. That would definitely something which would be really cool to have. What we can do or what we do in our build pipelines is that we just use an external validator. I think there's the Java validator in a Docker container or something, but not in production. No.
Thank you very much. We have another question over here.
Yeah, this is cool. I was curious, have you seen the protocol buffer definitions from Google?
I have.
I know it's like up to R4 last time I took a look, and I was curious, would you be interested in building protocol buffers for the other spec? I think you get with buff build protocol buffer definition. So your big switch statement, you can kind of sort of do the proto validation and the big one of in protocol buffer standards. So I think you get your validation with it. You can get your serialization in protocol buffers itself, as well as JSON and XML if you want it. Something to think about. And I guess the only downside is you don't really get the use of generics. But if you have everything over interfaces, I think it might be worthwhile to take a look at.
Yeah, I looked at the Google protobuf libraries. Like I said, only R4. They only have JSON support, no XML. And also they don't accept, last time I checked, they don't accept external contributions. And for all the FHIR, for example, the FHIR-Path implementation, I needed the flexibility to add my own methods and stuff like that. That's why I decided on building our own thing. I can look into it. So right now, we don't have the need for protobuf. What I like about this approach is that the structs are like really stupid simple. There's nothing in it. And with protobuf, you at least have something embedded from the protobuf library. But I think it should be doable to get some interoperability there. I don't know if this one-off thing you mentioned, in the end, it's still, the compiler always just does this with, in the end, it compiles down to just jumps in the assembly.
So maybe thanks also again from the whole FHIR community. I think it's always great when someone contributes open source libraries, especially when they aim for being fast, right? And essentially go seems to be pretty fast. Is there any more questions? If no, then another applause for Lukas.
Thank you.
Thank you very much. I think Bram, right? You also commented in the chat that you also work with Go and you will also present today in the afternoon, right? So yeah, it will be the next talk. Yeah, but it's not yet done, right? You will do it at. All right, perfect. So then, who is interested can continue learning about FHIR in Go there. Thank you very much.